Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is Muhammad Afiq Hakimi bin Rosli. I am from Polytechnic Oklahoma, and today I want to present about reorganizing facility layout of sub-assembly station for production process improvement. Okay, so let's go to the abstract. Okay, for the abstract in production, the layout of workstation is need to be well planned to smooth the production flow, especially in the assembly line, where there are sub-assembly parts that will affect the entire production process. This paper will be describe the implementation procedures and performance assessment based on the rearrangement of facilities at the assembly shop area. So the objective of this work is to implement the and organize the new layout of sub-assembly station at the chassis assembly line in order to improve the production process performance and reducing the production cycle time. As that, the fuel tank sub-assembly station is extract from the chassis line to allow the separation of assembly and sub-assembly process. So the result will be show the effectiveness of this strategy and the ability to achieve the desired reduction in the production cycle time. Okay, so let's go to the introduction. So basically, facility layout is an important component in the industry for the overall operations, effectiveness, and staff comfort. The function of the layout is to ensure the flow of the process, the material, and the information collect based on the actual production. So there is four basic layout considerations, which is shipping and receiving, the flow of movement, material handling, and space utilizations. So layout considerations must fit effectively according to the function and of the production plan. And facility layout in the manufacturing industry is very important to the production line efficiency to get a continuous improvement. So with a better placement in the manufacturing industry, will reduce the use of operating expenses up to 50% and minimize the cost by up to 30% per year. So basically, the importance of plan layout in manufacturing is human comfort, which is the backbone of success company in product development in a industry. So in production, the layout is need to be well planned to smooth the production flow, especially in the assembly line, where is the have sub-assembly parts that also affect the entire production process. So basically, there are two categories of sub-assembly, which is the major sub-assembly and minor sub-assembly. For the major sub-assembly, usually will be placed into a typical area, which is at the specific zone that will be named based on its parts. While minor sub-assembly station in the production line will results in the minor sub-assembly will be placed into a production line. However, some of the minor sub-assembly station in the production line will result for the additional time in a cycle time for the productions. Okay, let's go to the next, production process improvement. In improvement in the production process strategy, one of which rearrange the plan layout effectively. Strategic plan layout allows worker to work efficiently without having ergonomic issues and can achieve production target without any back order issues. So waste of movement in the factory will disrupt the production efficiency by removing any possible waste of movement and over process can help improve the production process effectively. For the example, such as a figure below, as you can see, such as shorten the way of path, or adjusting the place equipment or component might help workers perform better. In the lean of philosophy, elimination of waste being the main of goal to fulfill the customer satisfaction. So the lean for production also to making production flow to attract customers as well as pursuing the perfections. So basically in this project, the improvement of the production process is at the vehicle assembly line has been considered. This is due to the deficiency identified at the chassis line, where there is a production delay due to the fuel tank sub assembly station that has been implemented there. So let's go to the next part, which is excess workload at the assembly station. So in the additional of process in the station will affect the cycle time at the chassis line. Cycle time is a production of production time, total production time from the beginning until the end of the process. So cycle time can be measured based on the observation and results data. Manufacturing cycle time is an average time record for the whole process of manufacturing. So as you can see in the table below, the actual production time per car is not achieve the ideal target for the production time per car. The chassis line station's ideal target for average cycle time is 4.30 minutes to finish a sequence, but there are certain problems that prevents achieving the ideal target. So the actual production time in this station is only achieved for 4.71 minutes. Because of that, the daily target cannot be undone. Okay, next we go to the methodology. Basically, the overall process is to upgrade a layout with move the fuel tank sub-assembly station and its PC racks from the production line, which is in fuel tank assembly line, into the logistic area, which is right before the supply process happens. This change allow the separation of assembly and sub-assembly process individuals cycle time. Amongst the steps taken are problem clarification, root cause analysis, countermeasure implementation, and data analysis. So let's go to the problem clarification. Okay, basically based on the observation that has been carried out to list all the problems that occur, we have got a certain problem that has been identified, which is the first one is operator at the logistic area needs to commute the trip from logistic area to assembly line because of the separate parts. Next, the operator at the assembly line is having a high workload for sub-assembly and assembly parts. And the last one, space utilization at the assembly station is compact with the sub-assembly PC rack and the sub-assembly station. Okay, as we can see, the table at the right, which is show the ideal target of the production quantity and actual production quantity per hour, which is every hour there is one unit of back order product. All the back order products always need to catch up with to sync with the customer's demand, which is mean all the back order product will make an overtime production. Okay, after a problem has been listed out, the problem need to identify which the most critical effect of daily undone. All of this problem will be Gemba again to observe the whole process. In the Gemba process, all the feedback needs to receive the operator is high workload has been results in the delay production, which is the conveyor must stop until the fuel tank has fully installed in the chassis. So based on a table at the left, This is the current operation monitor for the chassis line at the assembly shop. So the actual cycle time at the chassis line exceeds the target cycle time, which mean the target of production cannot be undone. Okay, next we go to the root cause analysis. So after we observe, all the data will be analyzed using Ishikawa diagram. So as we can see the picture, the figure of the Ishikawa diagram shows the cause of delay of production in fuel tank station, which is the major cause of this problem is lack of planning on the process. Okay, basically the cost of this project is not lacking for the equipment or machines. All the parts in this project is already available, which is has been complete finished by other company. So based on the problem identified, the tow truck driver needs to send separate parts repeatedly and arrange them into PC rack, which will be because the process supply process is not efficient. While the operator experience a high workload from the additional sub-assembly process stems from the people, which is will cause ergonomic problems or ergonomic issues. For the material category, separate parts needed to be sub-assembly before assembling into the chassis, so it will be cause an additional production time to the station. And lastly, the environment of category. The sub-assembly station, which fuel tank sub-assembly station placed in the chassis line, will cause space compact for the operation to perform works. Okay, next we go to the implementation of the countermeasure. So in order to counter all the cause that has been identified, the countermeasure has been listed out as you can see in the table, and we have implement. This countermeasure are assigned to according the root cause problem at the chassis line. Firstly, what we need to do for the sub-assembly, the parts before the supply process will change the condition of the parts, which is from lot parts to the Jundate parts, which means a set of parts are ready to assemble for to the chassis directly. So for the support for this countermeasure, a special trolley is needed to store the finished sub-assembly parts. So a special trolley is built for the fuel tank parts is to increase the efficiency of the supply process. So when it has been implemented, the tow truck drivers are no longer need to supply separate parts repeatedly. Okay, next for the second one, the sub-assembly station makes the fuel tank station space compact. So when the sub-assembly station is moved to the logistic area, it automatically minimize the space utilization at the chassis line. So in order to move the sub-assembly station, we'll need another space that is more strategic, which is we can implement to the logistic area right before the supply process. So for the lastly, for the operator is having a high workload. Firstly, sub-assembly station need to execute from the chassis line to separate the process. After a place, the sub-assembly station at another place will add another worker operator from the logistic area to operate the sub-assembly station. So this planning will minimize the workload for the operator. So with this countermeasure that has been made to counter all the problems, statement is the most significant to achieve all the objective. Okay, next we go to the results and discussion. Okay, to achieve all the objective, results from data must be proof that all the implementation will succeed the project and achieve all the expected result. Before the execution of the fuel tank sub-assembly station from the production or assembly line, the operator needs to perform two processes that affecting their cycle time and make it overburden for the production line. So in order to reduce cycle time, the fuel tank sub-assembly station is needed to execute, which is separate into the another process. Indirectly, with the execution also will reduce the overburden of the operator. As a target from the production, request is to achieve the daily cycle time is 4.30 minutes and below to achieve the daily production target. Okay, so what we have here is cycle time is before and after. Okay, initially the current data also being to use as a comparison between before and after project implementation. All the record data are tabulate in the left table as before and after execution of the sub-assembly process. All the record data is taken based on the 3 average of readings with 5 random days in 5 slots of times. Okay, so as we can see, after the execution of the fuel tank sub-assembly station, the cycle time can be achieved for average 4.3 minutes per process at the time taken based on the standard of the procedure after the execution of sub-assembly station. So basically, after removing sub-assembly station from the assembly area, the cycle time will be reduced and able to achieve the targeted cycle time. Okay, next we go to the data consistency, which is we have a graph. The consistency of cycle time data will be collect for a newly implemented facility layout at the assembly area that has been observed. The amount of cycle time for different time slots after the execution of sub-assembly station is shown in the graph, which is the consistency cycle time obtained is very high due to the separation of both assembly and sub-assembly process. But the certain time, which is at the time 2 p.m, its reading slightly exceeds the standard of the cycle time. So from the observation, the cause of the reading is due to the operator is having a rest in the lunch hour. So the starting for the operation, operator is a bit lazy to perform the job. But the problem has been countered when the operator can catch up again, which is that can get 4.25 minutes to finish the job on time that later on. Next, there are certain reading that get less time, which is 4.25 minutes. The operator finished the job early. Basically, all the most perfectly achieved for 4 minutes and 80 seconds, which is 4.3 minutes. So all the data and graph is showing the consistency of the new cycle time that can be done. Okay, next we go to the total and average cycle time, which is we have to analysis that is very important to make a comparison because of the efficiency rate. A better average of cycle time can be determined based on how much time can be reduced with the actual target. So basically in the graph, as you can see, the result after the execution was far better than before execution, because of the graph is after is very slightly has going down for 2 plot, which reducing more of the cycle time. Besides that, the implication for the feedback has more advantages than before, such as the workload of the operator can be reducing to make operator perform their job. As a result, the overburden of operators can be reduced. Next, we go to the distribution by slot, which is this analysis will be focused on the consistency of the new implementation cycle time and human behavior. So there are a random choice for the time slot before and after the project implementation. So according to the graph, this is the most consistency in achieving the cycle time. From the observation, the cost of the operator can perform on that slots is because of after having a breakfast. So energy from the for the operator has been regenerate to perform the job better. So as a conclusion, that we can give here, the execution of the fuel tank sub-assembly station from the assembly station has been proved for its effectiveness. So with the result and discussion, can achieve all the objective and complete the project. Although the improvement were not very aggressive, the results and effects from the execution has been given get the positive feedbacks from the production performance. The recommendation for this project is to get better training for operators to perform better and get better consistency in the assembly process. Not only for this section but also for the other assembly stage section to get a better performance in production. So successful production can minimize the amount of overtime production, which can save more expenses for the company. So that's all from me. Thank you very much.